Unit 5, Learning Target 3, Solve a system of equations using substitution. This may be really confusing just from this video, and we are going to practice a lot in class, but if you can get it from this video, awesome, but we will practice a lot in class. Okay, so the substitution method. So we have two equations here. So substitute the expression from step 1 into the other equation. Okay, so what I always do is I take the one, so let me highlight this first. I look at the equation where it's already set up as like a y equals or an x equals. So this one is already set up as my y equals. So what that means is I want to substitute that in this value, so y equals 5 minus x, I want to substitute that value in for this y. So that's what I'm going to do. So the equation I haven't touched is what I'm going to write. So I have a 1 equals 4x plus 3, and then instead of writing y, I'm plugging what this y is now, because it says that y is this. So 3 times 5 minus x. Solve so that only one variable is left. So now we have a bunch of x's, and all we're doing is solving for x's now, right? So I distribute here. So then I have 1 equals 4x plus 15 minus 3x. And then I'm going to have 1 equals, what is this? X plus 15. Let's make that a plus. Then I can subtract 15 from both sides. And I should get x to be equal to negative 14. So when I distributed, that's what I'm getting. Did I write this wrong? No, 5 minus x, okay. So now that I figured out what x is, so take the solution from step 3, this is all set up wrong. So take the solution, so here's my solution, x equals 14, negative 14, and substitute into one of these equations. So I'm just going to put that negative 14 into one of these to then tell me what y is. It looks like it's going to be easier to plug in this one because there's a lot less variables and a lot less numbers to deal with. So I'm going to write y equals 5 minus, instead of x, I'm going to write my negative 14. Well, two negatives make a positive, or if you dink. So then I get y to be 19. So let's practice this with a bunch of problems. So again, here's my easy one. It's telling me right away that x equals 7. That's really easy. So instead of writing x's, I'm going to write 7. So now I have 2 times 7 plus y equals 5. 2 times 7 is 14 plus y equals 5 minus 14. And they cancel. Y, what is this going to give me? Negative 9. So now I don't even have to plug back in to find x because it already told me right here that x is 7. So now I know that x is 7, y is negative 9. So my easy one here, x equals 2y. X is equal to something. There's not anything with it. So now, instead of writing an x, everywhere where there's an x, I'm going to write a 2y instead. So 2 times, instead of x, I'm going to write 2y plus 8y equals 1. This is going to be 4y plus 8y equals 1. And then I'm going to get 8 plus 4 is 12, y equals 1. Divide by 12, y equals 1/12. Now that I have that y value, now I plug this y value, so that 1/12 back into one of these equations. So I could plug it in right there, but to me it looks easier just to plug it in right there. So I'm going to do that up here. So now I'm going to have x equals 2 times 1/12, which is going to be 2 over 12, which is going to be 1/6. So x is 1/6, y is 1/12. Alrighty, let's go to highlighter. The easy one here is a y equals 5 minus x. Y equals 5 minus x, because it's telling me already that y is 5 minus x. So wherever there was a y, I'm going to plug in 5 minus x. So now I have 1 equals 4x plus 3 times 5 minus x. Timeout. 4x plus 3y. This is the same problem. I'm not doing that again. All right. Over here, y equals something right away. Y equals 1.5x. So instead of writing y, I'm going to write 1.5x every time. I could have also done this one because they're both y equals, but this one has a lot less to plug in than this one. So instead of y, I'm going to write 1.5x, because I'm plugging this now into that one, equals 12 minus 2.5x. So now I add 2.5, that's a 2, plus 2.5x, cancel, 12, what is this going to give me, 2, 3, 4, divide by 4, so I get x to be 3. So now I take that and I can plug that into anything up here. I can plug it into this one, I can plug 3 in for x in this one, or 3 in for that one. I'm just going to do this one because it looks easier to me. So y equals 1.5 times 3. Remember, if you don't know how to do that, it's 1.5 times 3. 5 times 3 is 15. 4, right? And then there's one decimal, so I move it 1. So my y equals 4.5. Ooh, I don't know what that is. All right, special cases. So here we go. This one looks the easier one to me because it's already y equals something. So I'm going to plug in 3x minus 7 wherever there's a y into this problem now. So 12x minus 4, instead of y, I'm going to write 3x minus 7 equals 10. So then I get 12x minus 12x plus 28 equals 10. Well, these two are going to cancel. 12x minus 12x is 0x, so then I get 28 equals 10. That is not a true statement, so that means that there are no solutions. So on this one looks like the easier one to me because it's x equals something. So wherever I see an x, I'm going to do 4y plus 3. So instead of that x there, I'm going to do 4y plus 3 minus 8y equals 6. 2 times 4 is 8y. 2 times 3 is plus 6 equals, or minus 8. That's a big minus. 8y equals 6. So then my 8y's cancel, and then I get 6 equals 6. This is a true statement, so this means there are infinite solutions. Remember, we did this a while ago when we got answers like this. If it's not true, there's no solutions. If that equals something gives me a true statement, then it's infinite solutions. So those are special cases. So before class, I want you to solve this system using substitution.